lithography only we can add something or we can subtract something to create the pattern. Now there are two types of photoresist used. One is the positive photoresist, another is the negative photoresist. Positive photoresist are the resists. If that resists are used, we will create the pattern as per the mm, as per the mask. As per the mask, the patterns are created, and if the negative photoresist we are using, then patterns are created opposite of the mask. That is the main thing. And another thing is that positive photoregists are by nature they are in the solid form, but negative photoregists by nature they are in the liquid form. These are the differences. Now how this will be done, that we will see here. First, here it is shown that negative photolithography. Suppose we want to create a window like this, which is shown in the second diagram. Then for this, initially we have to apply the photoresist. Then how to apply the photoresist? Above silicon substrate will be there. Above this, suppose the oxide layer will be there, and uh, this oxide layer we want to create the window here. You can see the arrow or you can see the blue color. Here suppose you want to create the window, then above this the photoresist will be applied. Then photoresist will be applied by using the spin photoresist method. uh, then when the photoresist is applied, after this it is above this the mask will be kept. Then mask you can see outlines are transparent and middle portion is the dark region. Then after this it is exposed to the ultraviolet light. When it is exposed to the ultraviolet light, then the area or the portion which is exposed to the ultraviolet light, this will be become hard or become thick, because already it is in the liquid form. Then this will become hard or thick, which is exposed to the ultraviolet light. And the area which is not exposed to the ultraviolet light, this will remain as it is. As it is means this will remain in the solid liquid form only. Then after this exposure will be removed, and then after this the developer solution is applied, and the area which is not exposed to the ultraviolet light, which is uh, available in the liquid part, that will be removed out by using the developer solution. And the area which is hard, that will be written as it is. And after this, here if you want to add something within this window, or you can subtract something by using the etching process by within this window. Okay, then like this the window is created. Then this is negative photolithography. You can see the dark region uh, is is removed, and the transparent region will be as it is. Now in similar way, here you can see the positive photolithography. In the positive photolithography you can see the mask is opposite, because you want to create the window in between. Same structure you want to create, but here the middle portion is kept transparent, and outer portion is the dark. This is the mask. Now again the same procedure will be there. Initially the silicon substrate, above this the oxide layer will be deposited, or oxidation will be done. Above this the photoresist is applied. Now this photoresist is made solid, or it is available in the thin film form. And above this the mask is kept. When the mask is kept, after this it is exposed to the ultraviolet light. Then due to the ultraviolet light, what will happen? The area which is exposed to the ultraviolet light, because see in between here in middle square is the transparent region, and through that transparent region that ultraviolet light will fall above the photoresist, and here this part will become weak, or this part will become a soluble, or is available in the liquid form, and remaining part will be as it is in the solid form. And after this, when we keep this in the developer solution, or when we apply the developer solution, the part which will become weak, that will be removed away, and like this the window is created. Now within that window you can add something. If you can diffuse something, you can uh, by using implantation or diffusion, you can use the doping, or by using the deposition method you can deposit something, or by using the etching method you can etch the oxide layer within this window. Like this, if once the window is created, you can add or subtract something. 1 minute. ऋतुज, तुम्ही लोक ना एका वेळी दोन दोन कशाला नाही बरोबर आहे ते सकाळपासून बसले होते. Okay, now here we will see, means we have seen the positive photoresist and negative photoresist. Now we will see what are the 10 basic steps in the photolithography. First is the surface preparation. Means what? It may be the only silicon substrate or it may be the oxidized silicon substrate. But before doing lithographic operation, but after lithographic operation, we are going to add something or we are going to etch something. Then at that time, some initial surface preparation should be done, because if you want to add something and if any impurity will be present on the surface, then that will be add contamination, and to avoid this, the surface preparation should be done. What is mean by surface preparation? That surface cleaning should be done, and so that petty items or any particles will be there, that will be removed away. Sorry, a little disturbance will be there. Now second step is photoresist application. Already we know that there are two photoresist, positive and negative. Once the surface is prepared or surface is cleaned, after this the photoresist is applied above this. After this soft bake is done. Why soft bake is done? Because that photoresist should be get properly attached to that surface. Then to get it properly attached, or there should be a proper bonding between that surface and photoresist. For this the soft bake is done, so that it will be properly attached to the below surface. Then after this, align and exposure. Align and exposure. Align means here we have to use the mask, and exposure means here we are going to expose it to the ultraviolet rays. Then after this, developer. Development what? Once the exposure is done, the some part will be strong or hard. Some part of that photoresist will be hard and some part will be weak. Weak part we want to remove, and that can be removed by using the developer solution. That process is called as a develop. After this, hard bake means again it is heated near about 500 to 600 degree temperature for near about 30 minutes. That is called as hard bake. At the time of hard bake, if any leftover of photoresist will be there, if any particles of photoresist will be left within that window, created window, then that will be removed, that will be vaporized, and that will be removed away. For this the hard bake is done. After this, inspection means what? Whatever the mask we have kept, then as per the mask, that window is created or not, that inspection should be done. After this, etching. Here in this step, either we can do the etch or we can add something. We can, if we want to add by using doping process, then we can use the diffusion process, we can use the ion implantation process, and through that window we can add the impurity atoms within the substrate. That is nothing but the adding. Or sometimes we want to create the window, then here we have to use the etching. Means once the window is created, through that window we can add or we can etch. Therefore here we etch or we can add something. Once our purpose is over, after this we have to remove the photoresist. Then resist strip will be there and final inspection. Final inspection means that that pattern created is as per the required or as per the required dimension or not, that should be verified. So that is the final inspection. Like this, these are the 10 basic steps of photolithographic process. Then first, surface preparation. Already I told you surface preparation means what. Once suppose silicon substrate will be there, above this the oxidation will be done, or oxide layer will be there, silicon dioxide. Then above this, if any contamination or any dust particles will be there or any atoms will be there, then that will be removed away. For this procedure is called as a surface cleaning, or which is also a surface preparation. Then generally it can, this simple surface preparation, it can be heated for temperature near about 200 to 250 degree centigrade near about 1 minute. So that will be sufficient. Then next will be photoresist application. Then photoresist application, depending upon the which type of photoresist, which type of photoresist we want to use, we have to select either positive or negative photoresist, and that photoresist will be applied above the wafer by using the spin photoresist method. Spin photoresist method means what? Here you can see one spindle. Above this the vacuum chuck will be there. Above this the wafer will be placed, and from the photoresist dispenser the photoresist will be uh, some drops of the photoresist will be placed above the wafer, and after this spindle will be allowed, or this chuck will be allowed to rotate. Once it is rotating, the whatever the drops of this photoresist will be there, that will be sprayed on entire surface of the wafer. So here, like this, called as a spin photoresist method. So these are the some standards given. Dispense, how much quantity should be dispensed? This is near about the 5 ml of photoresist. Then spin photoresist will be 500 rpm. Then uh, the 3000 to 5000 uh, rotation speed will be there, like this. Then depending upon time, depending upon the rotation speed, that thickness of the photoresist can be achieved. The next step will be, again the same is shown here, photoresist application. Then after this, the soft bake. Why the soft bake is used? So that there should be a proper bonding between the surface and the photoresist. For this, soft bake is used. Here it is heated. See here it is heated for near about 200 to 250 degree centigrade temperature for 1 minute. Then that is called as a soft bake, and there will be a proper bonding between these. Again, suppose if uneven or unequal layer of the photoresist will be there, that will be vaporized and that will be removed away. So like this, that all that will be achieved by using the soft bake. Then after this, alignment and exposure. Alignment means here mask should be, initially mask we have to prepare, then mask will be placed above the resist. Again, by for placing the mask, again there are three different methods: projection masking, then some isolation should be there, or direct physical contact should be there. Like this, the mask will be kept above the photoresist, and after this it is exposed to the ultraviolet light near about 30 minutes. This is again the alignment and exposure. After alignment and exposure, again already I told you there are three ways to keep the mask above the photoresist. First is the direct contact, another is the proximity, and third is the projection. In the contact, the mask is directly placed above the photoresist, where there will be direct physical contact between the mask and photoresist. In proximity alignment, that mask will be placed above the photoresist by key distance. Is there will be no physical contact, there will be some air gap between these two. And in the third, the mask is placed far from the photoresist, and in between this, the mirror like projection system is used, where that exposure will be there. So like this, three methods of alignment will be there. First method, second method, and third method of the alignment of the mask will be there. And after this, that mask is that overall setup mask and that below photoresist all are exposed to the ultraviolet light. Okay. In the first, what is the drawback of the first system? First system drawback is that as if the mask we place above the photoresist, directly making the physical contact, after at the time of removing the mask, there will be problem that that mask may get tear, or that mask may get break to or that damage. To avoid this, the another method is used. Where drawback of this another method is that resolution or accuracy is not that much proper. Therefore, third method is there. But again, the drawback of third method is that setup is complex and costly. So like this, methods are there. Then next is the develop. Develop means what? After the alignment and exposure, the some part of the photoresist will become hard and some part will become weak. Then that weak part we have to remove. Then to remove that weak part, the develop operation is used. Here soluble areas of photoresist are dissolved by developer chemical, means that will be removed away. That is nothing but the developer. Then hard bake. Hard bake already I told you. Hard bake again after the developer or developer operation, some part of photoresist may get left over there. So to remove that, hard bake is used. Then inspection. After this hard bake, the inspection is done, that whatever the windows created, that windows are as per the dimensions or not, or any defects are there, any leftover again particles are there, all that will be measured. So that is nothing but the development inspection. The next will be etching. Either once the windows are created, we can etch. Then for this, generally wet etching is not used, because is there in wet etching, we have to keep that entire portion in the chemical or in the solution, and it is possibility that below the photoresist, what is the area protected, that may also etch, because we have, if we keep this in the wet etching solution. Then therefore, to avoid this, generally the dry etching is used, because only the window will be created, and through that window the plasma or ions are bombarded, and with this bombardment or ion bombard, etching can be done. So generally dry etching is done. Or suppose through that window we want to add something, or we want to use the doping operation, then we can use the diffusion process, or we can use the ion implantation process through that window, so that the impurity ions can be added through that window. So like this, once the window is created, we can etch or we can add something. So here the overall photolithographic diagram is shown here, all the steps. Initially the substrate will be there. That substrate is the oxidized substrate. Oxidized means what? It is oxidized from both the side. Again, it may be that wafer will be oxidized from one side, or two-sided oxidized wafer may be there. Here they have taken the two-sided oxidized wafer. After this, above this the photoresist is applied, that is the positive photoresist. Then above this the mask will be kept. You can see the mask, dark portion will be there and some of the transparent portion will be there. And after this, it is exposed to the ultraviolet light. Once it is exposed to the ultraviolet light, whatever the portion which is exposed to the ultraviolet light, that photoresist portion will become weak, and remaining portion which is not exposed to the ultraviolet light, this will be remain as it is, strong or hard. After this, it is developer solution is applied to this. Once the developer solution is applied, the weak part of the photoresist will be removed. Once that weak part of the photoresist will be removed, that mask is also removed. After this, the inspection is done. After this, hard bake is done, so that any particles of the photoresist will be left over there, that will be removed. And after this, inspection is done. Then finally, we will see like this. Then after this, once the required window is created, then through that window you can see here in this diagram the etching is done. Etching means below layer, which is the oxidized silicon dioxide layer, that is removed. So that is etching. But sometimes here you want add some another layer, then again that can be also done. So here in the next step you can do either etching or add something. Once our operation, or once our all the operations or advantage of photoresist is done, we have to remove the photoresist, that is nothing but the strip resist. So here in the live diagram you can show, you can see here that photoresist is stripped out. Once the photoresist is removed, again the final inspection is done. Okay, so here you can see photoresist removal. Again for photoresist removal, again the etching will be used. Here some there are the some agent solutions in which only the photoresist can be removed, they like this, or plasma etching also can be done. So there are again two methods for the photoresist removal: wet acid strip or dry plasma strip. Dry plasma strip means again by using the plasma that dry etching is done, or in the wet, directly in the wet solution, that put, entire slab or entire device will be placed and only the photoresist will be removed. And after this again the cleaning operation is done, and then the final inspection. So like this 10 basic steps of photoresist are there. uh, can I explain now for etching? Anyone? Tomorrow which topic you want? Anyone? Can you hear me? Saurabh?
Yes, madam.
हा, तर उद्यासाठी मला एक टॉपिक सांगा, कुठला तुम्हाला रिवाइज करून हवाय. कारण त्याची मला आधीच पीपीटी वगैरे डाउनलोड करावे लागतील, कारण मी इकडे गावी आहे. माझ्या लॅपटॉपवर पीपीटीज नाही आहेत त्या सगळ्या. नेटचा पण इश्यू, त्यामुळे मला सगळं आधी डाउनलोड करून घ्यायला लागतं. तर इफ यू डिसाइड इट नाव, टुमॉरो इट विल बी इझी टू मी. मला अटेंडन्स पण घेऊ दे. डिसाइड करून सांगा रे मला टॉपिक.
हो
इन
चालेल.
चॅट ऑल्सो यू कॅन. विच टॉपिक यू वॉन्ट?
हो चालेल मॅडम, आम्ही सांगतो. ओके.
काय झालं सांगताय का? Hello. Uh, you decide the topic and tell me the topic. Okay. On WhatsApp also you can tell me the topic, so that for that particular one or two topics I will take the revision tomorrow at the time of our lecture. Okay.
ओके चालेल मॅडम.
Okay. Okay. You can exit now.